Hello guys, in today's session we will discuss load and store functions. Load and store functions determine how data goes into PIC and comes out of PIC. PIC provides a set of built-in load and store functions described in the section part. So you can also write your own load and store functions, that is by using user-defined functions. So let's have a look at some of the load and store functions like bin storage, JSON Loader and JSON Storage, then Pig Storage, and lastly we are having Text Loader. So let's have a look with bin storage. Bin storage, it loads and stores data in machine readable format, and in this bin storage is used with the load and store function. So have a look with the sample data set like scat c.txt. So we're going to have a text file that will be going to load in relation A by using pig storage, and then we'll be going to dump that data and we'll be going to store that data by using bin storage, and whatever the output that will be going to generate in the particular path, that is bin underscore output, that output you'll be going to get in binary files. Now again we'll be going to load that binary file, that is path of binary file, by using bin storage, and again if you are using dump statement, in that case you'll be going to get the original data, that is the original output which was there in c.txt. So this is something the part for bin storage. And also pig uses bin storage to use basically for the loading and storing the temporary data that is generated between multiple MapReduce jobs. Bin storage works with data that is represented on disk in machine readable format. Bin storage does not support compression. Bin storage supports multiple locations like files, directories as input, and occasionally users they use bin storage to store their own data. However, because bin storage is a proprietary binary format, the original data is never in bin storage and it is always a derivation of some other data. So this is the part for bin storage. So I'll be going to show you practically, that will make you more clear for bin storage. So have a look. So at first move inside the grunt shell by using local mode. So here at first we'll be going to have the file that is c.txt. So that is in, as you can see, so that's our file in desktop itself. So this is your content for the data set which we are having in c.txt. Now I'll be going to load this data by using load command. Then here we do write the part that is the part that's c.txt, and that is using bin pig storage. So finally we are done with this. Now I'm going to dump the data by writing the command dump A. So finally the desired output in console that you'll be going to get, that is in this form. So this is the output for dump A. Now what exactly I'll be going to do is I'll be going to store this data. So for this I'll be going to write the command that is store A into, and here I'll be going to give the path where exactly I need to store, and I'll be going to store it inside the desktop itself, and here I'll be going to give the name as bin output. So that's the name which I have given for this, and here I'll be going to use bin storage. So here using bin storage, your B and S should be capital. So finally here, as you can see, the process has already been started and it is showing success. That means your bin output directory has already been created, and inside this you are having the output. So in this way you'll be going to get the final and desired output in binary file, in binary format. So you cannot it could not be displayed. So you can just have a look how it looks like. So for this I'll be going to write the command that is but for this you need to move inside bin output. So presently I'm inside desktop and I'll be going to move inside bin output. and I'm inside this, you're going to get the part. So this is the final and desired output which we have received in part hyphen m hyphen followed by 5 zeros. So you can just write the command as cat then part hyphen m hyphen followed by 5 zeros. Yep. So finally here, as you can see, this is basically your desired output, which is in binary format. So this is something, the part which we have used, that is by using binary storage, which we have stored the data. Now I'm going to clear this. Now what exactly I'll be going to do is I'll be going to load the data, that is binary data, which is present inside this binary bin output. So this is my binary folder. This is my binary output, binary data, which I'll be going to load it inside the binary storage. That is by using bin storage, I'll be going to load this particular data in relation A, and I'll be going to dump A, which will be going to give me the original data. So for this, I'll be going to write the command that is A again, where I'll be going to use load operator, and then here straight away I'll be going to drag this path over here. So finally for this I need to remove this extra single quotes from here. Yep. So finally we are done with this, and here, but before that we need to move outside this particular directory, that has been output. So presently we are inside this, and I'm going to move outside. Now I'm inside the desktop, and here I'll be going to use the load command, and straight away I'll be going to drag this part over here, and here I'm going to use by using bin storage. Now we are done with this, and finally your path has been processed. Now I'm going to use the command that is dump A, where I'll be going to get the as it is output, which it was the original data which I'll be going to receive in the console. So this is how we have done the part for binary storage. We call it as bin storage. So this is about bin storage, where at first we have loaded the normal data, and that we have by using pig storage, then we dumped it, we get the desired output, and after that we'll be going to store that output in in one of the directories by using bin storage, which will be going to give us the binary files in that particular folder, as we have seen with the bin output. Now after that, whatever the output which we have generated, that's in binary format, that output again it will be going to load in relation A by using bin storage, and after by writing the command dump A, will be going to get the again the original data. So this is for bin storage. Now let's proceed ahead. Now we'll be going to have reading JSON data with JSON Loader. So Apache Pig can read JSON formatted data if it is in a particular format. So each row in the file has to be a JSON dictionary, where the keys specify the column names and the values specify the table content. So here, as you can see, the sample data set which we are having, where we are having key and value pairs like food and tacos, your person, allays, that amount 3. So it's basically a key value pairs over here. So there is no concept of a delimit in JSON. That is especially in your JSON loader or your JSON storer. So the data is encoded in standard JSON format. So JSON loader optionally takes a schema as the construct argument. So this is about the JSON format, the JSON data which we have seen. So now we're going to use JSON loader to load data, and this data is loaded with a schema. So finally, by using this particular command, so in this part we have taken the name of the relation as JSON data. You can take it as A, B, C, or anything. And here we have load the second table.json. So basically the JSON data which will be going to load over here, that is by using JSON loader, and which consists of three sections, three fields, that is a food, person, and amount. And finally, by using the command dump JSON underscore data, we'll be going to get the final output in console. So Now writing data with JSON storage. So for this we're having a sample data in first underscore table. So this is your sample data we're having, and here I'll be going to use the command that is a equals to load first table dot that is basically the file name which you have taken, this first underscore table, by using pick storage as followed by the column family. So here basically the first column we have named as col1, which is of character array format, and then we'll be going to store this particular relation into first table dot JSON by using JSON storage. That is something we are trying to write data by using JSON storage. So as at first we have seen the part for JSON loader, and now this is the part for JSON storage. So let's check it out practically. That will make you more clear. So first I need to clear the screen. So here we are having a first table which consists of this. So this is a sample input for first table, and then we are having second table dot JSON. So this is your JSON format data, and next we are having data JSON for this. So let's check it out what exactly the things we'll be going to do. So at first I'm going to have the second table dot JSON. So this is our sample data, second table dot JSON. So this is your JSON format data which we are having. I'll be going to load this in relation A, or in JSON data. So for this I'm going to use JSON underscore data, or else in short I can straight away write the path command as I can take it as the alias as A. So here I'm going to use the command that is load, then second underscore table dot JSON. Yeah, so finally we have done with this, and here I'm going to use by using JSON loader. Here J and L should be capital, and here I'll be going to define the fields. So starting with first, that is food, which is of char array. Then we are having person char array, and then amount, which is in integer format. So finally we are done with this, and here I'll be going to dump this by writing the command dump A. So finally you'll be going to get the desired output in console. That's your JSON data. Okay, it is showing an error. Just a moment. So basically here I'll be going to take the part as data.json, and here I'll be going to dump A. Yep, so finally here as you can see the other part has been loaded successfully in this section. So this is our sample data which will be going to take the part over here. So we're going to take this particular as your JSON data. So as you can see I'm having the so this is basically the thing which we have taken successfully, as it was showing an error for this. I guess some sort of some mistakes are there. As you can see, some of the sections are in brackets, so that's why it was not taking the part. For that we need to define it separately. So for this we have taken the sample, that's your data.json, that's the part, and here as you can see we're having three fields for food, then for person, and then we are having amount. So this is how basically we are having the JSON data, that's your data.json. So finally we are done with this, And next part here, so this is how basically we have used the JSON loader, that is to load data, that is with a schema. Now we'll be going to check out with JSON storage what exactly and how we'll be going to store the data. So at first have a look with a sample, but before that we need to clear the screen. So have a look with the first underscore table. Yeah, so here this is a sample data which we're having, that is tacos, then tomato soup, then grilled cheese. So this is basically the main input basically which we are having in this particular JSON. That's basically the data, a sample data. That's your first underscore table. Now I'll be going to load this table by using pig storage, and here I'll be going to define the part as for first column. So here basically it consists these data, these values in first column. So at first I'm going to use the command that is a, then I'm going to load this, and here I'm going to load first table, first underscore table, and here by using pig storage. Yeah, it's pig storage, and here by using as clause, and here we're going to define the field. So that is col1, which is of char array form. So finally we are done with this. Now I'm going to store this by writing the command store a. This is the first relation, so store a into the table that I'll be do. That's basically the directory. It's in JSON format, so I'll be to use as first.json. So that's the name of the JSON file which I'll be going to give, and by using JSON storage. So here basically I'm storing this particular relation output by using JSON storage. Using JSON storage. So finally here, as you can see, process has already been started and 0% completed. Now it is showing as success, so you can just check it out. So first.json, so here you can just check it out. So this is basically the output which you have received for column 1. As you can see, we have received the values. So this is for key, and this is for the values which we have inserted, only the values, that is in first dot table which we are having values, and here in this format you'll be going to get. So this is in JSON format. This is your input data which is in JSON format. So this is how basically we write JSON, that is writing the data with JSON storage. So this is the part. Now let's look ahead with pig storage. Now we'll be going to have pig storage, where it loads and stores data as structured text files. So at first we'll be going to have a sample data, that is data 3, which consists of 3 fields, f1, f2, and f3. That is by using pig storage. /t is for the tags, that is your text as in the form of your, that is a tab delimited form, and you'll be going to dump a, and in this the pig storage stores the contents of eggs into files with fields that are delimited. So basically here, as you can see, we're going to use pig storage. By using pig storage star, by giving star, the output will be something, whatever basically the input you'll be going to have, like 1 tab, 2 tab, 3. So after dumping you'll be going to get the output in 1, 2, 3. But after storing, by using the command store a into output, using pig storage, by using asterisk as we have given over here, so based on that the output will be going to generate, that is like 1 star 2 star 3, like that. So I'll be going to show you practically, that'll make you more clear. So pig storage is the default function used by pig to, that is to load or store the data. So pig storage supports structured text files in human readable or else in UTF-8 format, which is in compressed or uncompressed form. So all pig data types can be read or written by using this particular function. So the input data to the load can be a file or a directory. So let's have a look practically. That'll make you more clear. And as we have already seen with the sessions in the earlier as well as in this particular part, that by using Pig Storage, how we deal with it. So have a look practically. That'll make you more clear. So again, at first I'll be going to clear the screen, and here straight away I'll be going to take the data that is data 3. So this is my sample data for this particular part, that is for Pig Storage. So at first I'll be going to load the data by using the load command, and here we're going to use data 3, load data 3, and here by using Pig Storage. Yeah, and here I'm going to use the delimiter, that is /t, that defines your data is loaded in a tab delimited. As you can see, it is in tab delimited itself. And here by using as clause, here I'm going to define the fields, that is f1 in integer, then f2 which is also an integer, and lastly f3 which is also an integer format. So finally we are done with this. Now by writing the command dump a, we'll be going to retrieve the output in console. So this is basically the data which we have loaded in relation A. Now I'll be going to store this particular output in the other directory by using Pig Storage and asterisk followed by the parameter that you'll be going to pass as asterisk. So have a look by using the store command, A into followed by the name of the part. So here I'll be going to write as pig out. So that will be going to create inside the desktop itself, and here by using Pig Storage, your PNS should be capital, and here we pass the parameter that is star. So finally we are done with this, and 0% completed. Now finally we're going to show us the desired output, that is showing as success. So we can just check it out as inside the desktop we can have a look. So that's our direct output in pig out, so which is in this particular form. So as you can see, now the desired output looks like this. So at first we have inserted the data that is by using delimiter, that is tab, and now it is delimiter is your star, which we have taken by using Pig Storage. So this is the part for Pig Storage. Now let's proceed ahead with this session with your text loader. When you talk about text loader works with unstructured data in UTF-8 format. Each resulting tuple contains a single field with one line of input text. So at first we're going to have the data set, that is data.txt. So it's a sample data set here. As you can see that in this we have taken as the Apache software, library, framework, processing, large. These are basically the keywords which consist of this particular data.txt. So this is a sample data set. Next we'll be going to load this by using text loader, and finally we'll be going to dump, and you'll be going to get the desired output. So we'll be going to check out with this also practically. But when you talk about text loader, it as I already said, that it works with unstructured data, that is in UTF-8 format. Each resulting tuple contains a single field with one line of input text, and also a text loader supports compression. So currently text loader support for compression, which is in limited part. So have a look practically, that'll make you more clear. So at first I'll be going to clear this screen by writing the command clear. Now I'm having the data.txt. So here, so this is my sample data set. So this is my sample data set over here. So at first I'll be going to load this data, or else you can just check it out, cat data.txt. So that's a sample data set. At first I'll be going to load in relation A by using the command A equals to load, then data.txt, and here by using text loader. your T and L should be in large. So finally we are done with this, and simply I'll be going to dump A. So 0% completed. The process has already been completed, half the section. Now here, as you can see, now it is showing in a parenthesis. It's the Apache Hadoop software library. So this is basically the final and desired output which is being showed over here. So this is basically showing the result in tuple, which contains a single field with one line of input text. So this is basically the part for text loader. So this is how we deal with the loading and storing functions, which is basically the part of built-in functions, and it determines that how data goes into the pig and comes out of a pig. So this is all about load and store functions.